Ramesh, I'd just like to start off with you. I mean, history and from historically, data analysis has been done in a batch mode. Where you had nightly jobs, files being pushed to FTP, and a bunch of other related things like that, right? And today we're doing more
Mhm.
real time. How you seen the evolution over these years, and how have you seen the companies that you worked with and in the industry, whole moving from this whole mindset of doing data analysis at the end of the day to more real time, instantaneous. How's that transition been, and how's it? How do you see it?
Um, I'll take my experience with working for one of the large online peer-to-peer wagering platforms at Betfair. Like you said, initially we did an overnight batch process in terms of fraud, risk analysis, and even and taking the website logs or the financial information of betting patterns and then crunching it overnight, and even with the banking sector in terms of derivatives. When I was working in the UK, all this was crunched overnight with huge clusters of machines, and then coming back the next day. Um, I think that model is broken now because now the model with most of the industries and what the consumers demand is instant feedback, and they're used to that. So even at Betfair, we went from a transition. Some of the issues we encountered is um, because the overnight batch processing, Betfair was taking a huge amount of losses in terms of fraud and risk, especially um, people funding the platform with stolen credit cards and that sort of thing. So we had to move away with the risk to the business to something which is more real time. So trying to identify the key thing for us is trying to identify key things in the business which had a sense of urgency, where the urgency is there, or there's a window of opportunity which you needed to take advantage of, and moving that in terms of prioritizing, moving that into a more real-time process. Um, I suppose going back, 20 years ago, 15 years ago, we didn't have the capability and the tool sets to do that. But now, with the cloud platforms and managed services which are there, I mean, moving more into a real-time processing where we can feed, using event streaming and learning models. Some of the things we did early was, in terms of fraud risk analysis, was look at betting patterns coming from Eastern Europe, or people using um, for a security sort of question was, if you're from Eastern Europe, you'd use what is your year of graduation, whereas in the West, you use your mother's maiden name or your pet. Um, so basically, the minute you know that somebody's used that question, you attach a tag to that, and then you start profiling them, and then see, okay, there's an activity there, and this all happens in real time. So you're just attaching different tags with different um, sort of signals and picking it up, and then that process it. And it's a learning model. And that was still not, I mean, going back to 10, 15 years ago, it was still a little bit, there was a time lag. But nowadays, what we're seeing is it's when I'm in real time, is true real time. When a customer comes in, you can analyze not only on their behavior, but you can take the cohort behavior analysis and apply that to the customer. What's the probability that they will take up a product, or risk analysis for them? So I think the industry is moving definitely in the right direction with the tool sets and the capability. But also, I think there's maturity with skill sets as well. What is available.
Right. And so, Ramesh, you bring an interesting point. The whole point of capturing as many signals as you can about a transaction, about the user, and then
Mm-hmm.
using all of those signals, attaching tags to them, and doing analysis or fraud detection on top of that. And
Mm-hmm.
uh, so that's a great point. And Punesh, just continuing on that thought, right? And you come in with a lot of experience in the heavy industries and aluminiums, and also much of other industries, but uh, similar to retail, where you have a lot of signals coming in your space, of IoT and heavy industry equipment. um, how do you sort of deal with so many different signals coming in, and what are some of the interesting use cases that you have seen in your vertical, more related to real time analytics and real time decision making, or uh, you know anything from that side that you would like to add?
Yeah, sure, Sri. Um, okay, but before I say anything, right, I have to put a disclaimer that all opinions are my personal, right? So I'm here in my
Sure.
personal capacity. But that said, right, so see, to your question on how the industry is moving from batch to real time, right? So this is something that we discuss and debate ferociously every day, if not every day, for every project and everything that we do, and not only now, right? So this debate has been ongoing forever, in the sense that this has been there forever. And in my roles, as I think, fortunately, I've played roles on the both side, as a technologist and also as a business user also. But one thing, right, so that this is not a direct answer to your question, I'll come to that, but at least one question that always puzzled me, that I kept asking myself, is that if you give a choice to a business user, right? So you say that on one hand you will get real time data, on the other hand you'll get batch data. A business user would never pick batch data, right? So imagine going to a business person and say that, okay, you have this data that is available now, versus this other option where your data is available only after 2 or 3 days. So the way, at least I look at real time, the entire concept of real time data, is it's a technology problem, right? So business user never ask for a batch data. It's us as technologists, maybe because of maybe budget is some constraint. Budget used to be the reason, I believe, but no longer. I don't think budget cannot be a reason anymore for developing a batch solution.
Mm-hmm.
That said, right, so coming, and this is very apparent and very visible even in manufacturing industry. Not all the systems, in the sense, when for example, when you go to your production line, or when on the shop floor on the manufacturing systems, right, there the data has to be real time, in the sense that you cannot operate without right, so it will break the entire line. So it has to be real time. Real time is split seconds. If it is going to take, if unless you know that your signal is going to cross your threshold in the next second, if you don't get an alert sometime immediately, right, so the entire line is going to be broken. It's so wherever a business needed real-time actions, right, so the way, I think, maybe one way to look at it is, wherever needed business actions, as in, if I don't know something is going to something is going to cross my threshold, which is going to break my process, which is going to impact my business, those are already taken care of, right? So because it's necessity, you don't have to go and tell anyone and everyone saying that you build a real-time system. But I believe what there's a huge potential, what very less people pay attention to, is these other processes. If you make them real time, what is the true potential, right? So it's I would not say, what I'm trying to say is that don't look for a use case first. You make a system real time. You make sure that you provide the data as a real time to the end users and business, and see the magic that they're going to do with that, right? So don't constrain yourself by thinking that if I have real time data, I'll be able to solve 10 use cases. I believe maybe we are at a point, especially with the cost of processing or whatever, right? So maybe the stream processing, the ease at which you can start experimenting. Maybe this is one path that everyone should start exploring, especially large enterprises.
Right. So you're bring an interesting point, which is basically no business would ever say, I don't want real time analytics. I don't want
Yeah,
real time
true,
data.
true. Yes,
So
it's our problem, right? As a technologist, we need to fix it. We keep giving reasons that, oh, that system takes time, this and also, but yeah.
right. And when all of these, so many signals coming in, right, and there's this tendency of technologists, that say, right, to get into this space of uh, let's collect whatever data comes in. I don't know what I'm going to do with it, but whatever signals come in, whatever data points come in, let's just put it up and put it into a data lake, and we'll figure out what to do with it later, right? So there's so at least what I'm seeing is there's a tendency for technology people to collect as much data and then hunt for a business problem. And maybe there's a right way to do it. Maybe that's the right way. Maybe that's a waste of resources. But what's your take on that, right? I mean, and I don't know, Ramesh, do you want to go first? Purnesh, you have a thought on that?
Uh, Ramesh can go. I can go next. That's fine.
For me, I think the way I've tackled in 2 or 3 businesses before is um, um, the signal still comes through in a pipe, and then how do you deal? You can tap into the signal and deal with it. So for me, I view it as if I'm an air traffic controller, I'm sitting in it, and I want to look at all the signals that are coming in, but then there's some signals which I'll pick up and deal with it. So in terms of coming into one pipe, everything that's happening on our platform is coming in, and then I take a tap from that, and I'm not worried about the accuracy of that, or I'm not trying to do an aggregation or anything. What I'm trying to do is signals, and there's an urgency, and there is a time-bound ticking a clock against that data in terms of the validity of the data. It's only going to be valid for maybe 1 second, 2 seconds, 3 seconds, or 10 minutes, or 10 days. So you want to deal with it straight away. So that's dealt with a certain area of the business or a platform that I've written. The same data could end up in a data lake, and there's a lot of things which will end up in the data lake. Sometimes it's almost like a dumping ground or a bin where, like you said, everything puts in, but the real-time stuff is where it goes in, and I take a signal. So one of the examples is we did before was if I go to a car dealership and I'm trying to buy a car, and if I pick up that signal that I've gone in and looked at a car, there is a window of opportunity there for different businesses to monetize on that. So what do I do? Potentially I'll buy a car, but before I buy a car, I need to get a loan for the car. And then I need to get an insurance for the car. And that is time bound within maybe a 30-day window. And after that, data is stale. So again, I go back to the urgency and the window of opportunity. And that's where the real-time stuff comes in. I suppose it's not as critical from an IoT perspective. So in the current business that I've got, which I'm working for, which is the sports technology business, which is IoT, is where we need to know the signals when a goal is scored, or Sachin or Virat Kohli has scored a 6. We've got cups and devices where we need to flash, and the fan engages at home, and we need to know that. We need to process that in near real time. We need to process the data and give it to the customer, the fan experience, before even what they see on the screen, and that's time critical. So there's 2 things. The same pipe comes in, same data comes in. There's a real-time urgency stuff which we deal with, and there's another one which goes and sits in the data lake. I think those are the 2 things which I've done, and that's working for us. Yeah.
Right. So what you're essentially saying is segregate by recency or urgency of a data packet, and extract what is necessary to make a real-time intervention. The others can go into a data lake for more further analysis later on.
Yeah.
Okay. And Purnesh, you wanted to add something to that?
Yeah, sure. But first of all, I don't have the right answer if you're hoping, right? So I'll just share my perspective. I don't, in my experience, at least there's absolutely no right answer, but because I've seen it play both sides, in the sense that, so when you go to a traditional business, right? So not necessarily anything, or a plant for that matter, they might be confined in thinking that my storage is so precious. I can only store 90 days of data. I can only store, any data, could be quality related data or machine data or anything. And they might purge the data so frequently. And over a period of time, we have lost so much data that could have helped us, maybe improve a process or something. That's on one side, right? So where there the opportunity clearly again is, I'm going back to the pace at which technology is evolving, right? So there is, it definitely doesn't cost as much to store data now as it used to maybe 10 years ago, and it's super easy to archive the data forever also. But at the same time, right, especially in an industrial IoT kind of a setup, you get hundreds and thousands of tags or data points just from one manufacturing plant. Now you multiply that with maybe tens or hundreds of clients that you have. The other side of the argument is, okay, I'll just dump all my data onto the data lake and I'll figure out at a later point. Quite honestly, I haven't seen anything meaningful come out of such an approach as well. So unless I'm not saying that you need to define exactly what you're solving, but a data dumping approach towards building a data lake is, it's highly, at least I may be wrong here, but I haven't seen it pan out, right? So because what happens is that when someone is actually trying to understand the nuances of the data, when you are trying to solve a problem, it never pans out, right? So you definitely need to know why you are storing data, how long you're storing data. You cannot take a convenient decision that I'll just dump my data in data lake, right? That's never a right strategy. I think that to me is convenience rather than the right thing to do. But so
Yeah, no. So you're essentially saying that it's always used. It's important to at least know why you're storing the data, and don't just put it in because storage cost is cheap.
exactly, yeah, exactly, yes.
Yeah, great. And so the next question that I was having is, with there's so many new technologies that have come up, in the space of real-time analytics, right? I mean, there's so many different players, so many different vendors, cloud, and so what's your go-to stack, like, so to say, right? What is the technology stack that you feel works well for, let's say, the industrial use cases and for the sports fan engagement use cases, right? What are some of the technologies that you think have really stand out and solve a lot of problems? What is your pick? uh, Purnesh, you want to go first, or?
Okay, sure. Okay, look, I cannot give out a stack, or I cannot call out I cannot take any names of vendors or anything, unfortunately. However, right, so I will put it this way, that and I'll try to I'll give you a long answer, right? So,
That's fine.
at least I think that space is very interesting, right? So, especially real time, if you look at real time analytics space or just analytics space in general, right? So the more number of startups are trying to solve very unique problems. So maybe real time is one space. Maybe someone is just trying to solve data integration space. Someone is trying to solve storage layer. Someone is trying to solve the more efficient layer, right? But I would put it in terms of, especially your stack. I don't think one of the biggest lessons that I learned, I'd made a mistake, fortunately, early in my career, is I used to stick to one stack and think that, okay, this is my golden stack, I'm going to die with this, right? So, but the pace at which the technology is evolving, what I would say is that develop some habit or a culture or risk-taking mechanism where you can keep constantly experimenting with stack. So whenever you fail with a new technology, right, your team or someone should not be so punishing, but at the same time, your core fundamentals. So for example, when I talk about large enterprises, right, one of the biggest decision that someone has to make is on-premise or cloud. I'm just taking simpler examples. So such are the things that you cannot mess up, right? So those are the things you cannot make a bad decision and say that, okay, I'll retro it or reverse it 1 year down the line. Those are extremely important basics, fundamentals. You need to spend as much time as possible and then take the right decision, right? There you cannot mess up, no experimentation there. And maybe the next layer, if you decide to go with the cloud, maybe, different cloud options, uh, slightly better than deciding between on-premise and cloud. But here also, I believe it's important to choose your primary cloud provider, have a strategy on how you're going to do. That's also important. This is also a decision that you cannot easily retro it. And so what I'm trying to get to is that if you think of this as a pyramid, right? Your bottommost is most rigid. You have to spend a lot of time there. But your topmost application layer, you keep experimenting, I believe. And if you look at fundamentally also where the innovation is happening, the innovation is happening only at the very top layer. So, and that to me is an area where you can experiment, fail. If it doesn't work, move on quickly, learn lessons and move on quickly. So keep a little flexibility in your stack and let everyone experiment. You provide the foundations, provide all the tools, and then let the stack evolve.
No, that's interesting. So you're saying keep your fundamental decisions very strong, but as long as you've chosen a particular architecture style, for example, then within that architecture style, maybe there are 2 or 3 tools. It's okay to experiment between them.
Right,
Yeah.
exactly. I think that's a good point that you made, right? So architecturally, so if I can just add is, you need to make sure whether your architecture is real time, whether it supports real time. You may not do real time today, right? So, but it should be capable of doing in the future. When you want to enable it, you should not say that, oh, oops, I don't have that facility, right? So that's a no. As long as your architecture is strong, different tools can always evolve. So,
Great, and thanks, Purnesh. I mean that's enlightening. Ramesh, you had you have a point of view on all of this complex mess of technologies that we see. Is it uh, is it really a mess? Is there a golden path? Or really do teams have to experiment with several different technologies to come up with something that's useful for them? Uh, what's your take on that?
I think, I'll go back to, I was working for an ad technology business, startup. We were pretty successful in 2015. Early days, like Purnesh was saying, we were experimenting. Yeah, we made some fundamental decisions. Like say that, the bottom layer. That took a long time. That was based on the architecture. That's an approach, and we took um, those decisions take a huge amount of time. So we chose a cloud provider, we chose an event streaming platform and an approach. Even with the cloud provider, we were looking at there's quite a lot of different solutions, but we chose one and we went with that, and that became the building block for everything that we were doing. But we went down different paths, and some of the paths led us to hit. We were hitting limits with what we could do with that. That didn't stop us, but what we went is we said, okay, we've hit the ceiling there. We stop. We take a step back and move on to another better product. I'm not taking product names because specific product we hit some roadblocks. But what we also really that product really worked really well from a scaling perspective and from a cost perspective as well. And what in the recent the last 6 months, I've been looking at a similar sort of solution, real-time requirements that we have. But what we found is we have learned from the last 4 years what are the drawbacks we've had, and we spent about 2 months looking at what the fundamental block looks like for us in terms of choosing the right tech stack. And we go with a dicey or a scorecard approach in terms of what are the non-negotiables that we need, and if the tech stack provides that or not. So in the end, if you go with a scorecard-based approach, you automatically arrive at a decision. Okay, this is the right thing for us, and we went with that. I think Sri, you're aware of what you've done. The other thing also is some of the things we had is the usual thing about build versus buy. With startup, we got a small team. We want to do things fast. We want the latest and greatest, but we don't necessarily have all the skill set in house. So what we tend to skew towards is looking for a managed service that we can buy, and then which scales with us as the business grows without a cost blowing out of proportion. So those are some of the things which we would look at. The other criteria for me is as the business scales, I don't want the cost going out of proportion. Ideally, I would like to see as the business goes into year 2, 3, and 5, the cost to service per user actually comes down. I think that is one of the fundamental things that I look for in terms of when I'm advising startups and clients. So you got to factor that in. You got to do some modeling in terms of what does the modeling look like from the cost modeling. If I go 10x, 100x, 500x, what is the cost for doing all this?
Great. No, that's an interesting point of view, Ramesh. I mean, Ramesh, you started talking about earlier about risk and fraud management, fraud detection, right? And obviously, with real time, one of the motivators is to make some decisions real time, and obviously, a human cannot sit and investigate that in real time, right? So, what are some of the machine learning, architectures? And you don't have to name products, but what are some of the architectural styles that you've seen in towards this whole machine learning, and how does an organization move towards real time detection of using machine learning to detect, like in your example, right? uh, Sports engagement, right? Where is the play of machine learning in that, and uh, what kind of an architecture do you recommend to sort of do those things, machine learning in real time?
Look, the sort of things we have done is, you've obviously got, you know your business better than anyone else, each one. And then there's always the manual analysis that goes through. And then we all have different data sets at our disposal. So what we do from a risk analysis, for example, in the betting industry, what is the probability of this individual, being a fraud or doing a fraudulent transaction? And there is some signals for that. So we would train the models and look at the data sets. The sort of data sets I'm thinking about is postcode, place of resident. Where is your traffic coming from? Is it coming from proxies, VPN, country of origin? And then if you can get some latency information, all of them are signals. And then you train your models in terms of, okay, what is the probability with X, Y, and Z? The probability that's a fraud case. Some of the other things we apply, which I know one of the betting industries applies, is what is the probability of a particular horse, coming, first in the race. I say first in the race, but that's I'll be a millionaire by now if I could predict a horse winning. But some of the things they look at is what is the moisture content in the grass. Did the horse travel over the last 2 weeks? How many races has it run? Did it run a 2 kilometer race, 3 kilometer? All these are different factors which go in, and you train the model. And then what happens is a new event comes in or new transaction comes in, and it just applies, okay, this one, apply this against that model, and it comes up with a probability to say, okay, there's 65% probability that this is going to happen. So again, right. The different signals, and you train it, and then each new transaction which comes in, you pass it to that, and this happens in real time. So the training of the model, it matures as we go along. Initially, the probability is probably, the accuracy is probably maybe 50% or 45%, but over the course of the time, you increase the accuracy of the model, and then anywhere between 67, 80, that sort of probability, that's pretty good.
Right. And so, I mean, you brought an interesting point, right? At the end of the day, machine learning, you still need a lot of probability and stats and statistics and maths behind it to sort of model some of these things, which is a point, at least, that I took away, that you need to, you can't go away from a basic statistic knowledge in spite of whatever algorithms are out there.
Yes, I would say so.
Yeah. That's it. And Purnesh, just coming over to you, and in the industrial space, right? I mean, predictive analytics, and I know that we've done some root cause analysis using machine learning in the past. And so, what kind of architectural styles have you come across and you recommend towards machine learning, especially in the whole, how do I predict if this machine is going to cause a problem, or how do you preemptively find out if issues are going to occur and then sort of work with that? And so what are some architectural styles or principles that you follow to sort of build such systems?
Yeah, sure. So it's important to understand, I think, while I believe when you Google machine learning or analytics and manufacturing, right? So probably the usual suspects around still there. Okay. The usual suspects around predictive asset maintenance or related to operational efficiency, all this would come up. But one thing, at least the problems that we are working, right? So the fact is that all these are, I'm not only talking about my current company, but in general, right? These Fortune 500 companies are extremely successful. They're Fortune 500 because for a reason, right? So they have been doing something consistently well for many, many years. What that means is that they would already have a highly stable process, and they would have so if you look at quality as an example, Just to give you some perspective, right? So why give you perspective on what I'm talking about. If you take quality as an example, if someone is if let's say you're producing 1,000 units of something, okay, it doesn't matter anything, maybe this phone or glass of this phone. Now, out of 1,000 units, typically, if let's say 400 units are of bad quality and 600 units are of good quality, it's a relatively easier problem to model because you have a good sample data sets on both sides. But what if you have 998 good quality products and just 2 bad quality products? That becomes an extremely hard problem because the existing bar is already very high. That I'm talking about thousands, but usually parts per million is the number, and then per a million parts or per a million anything, right? So in general, any manufacturing industry. So the number of defects are quite less, maybe 5, 10 or something. So when you're talking about a 5 defects over a million scale and trying to model that is, it's not, you cannot apply at least whatever we have learned in the consumer space directly onto the manufacturing. So it'll simply fail. So this is as I said, right, extremely difficult problem, but equally important and high value, because at that rate, even if you move the needle just a little bit also, right, so you're suddenly industry leading. Or you're suddenly moving a very large part of your business. So this is quite exciting. And of course, you are doing this on the difficult piece. One is that first of all, your sample sizes is not even. Second is you're trying to deal with, let's say, thousands of data points that are generated every 20 milliseconds or 30 milliseconds, and combine that over multiple years. You have an extremely large data set overall. But then within that, when you're looking at your good bad composition and you're trying to understand it, it becomes even more complex. But so that's that's what makes it interesting also. But couple of but one thing though is that at least I could talk about it with reasonable confidence, is that this is a space that's evolving, and you don't find much literature out there. What that means is that so probably what some company that's out there in the western part of the world may be solving a similar quality problem. They may be facing a similar challenge that we are facing in India. That's quite unique. I cannot say that with absolute confidence for, let's say, a churn model, because anything related to a consumer space, because I believe some other industries or some other countries have a head start on that. But I believe industrial analytics space is where it's almost the same. There's no blueprint out there. Some of these maybe predictive asset maintenance, while it's a broad topic, it will have to get into specifics on whether it's predictive asset maintenance in oil and gas or process industries or discrete industries. We'll not get there, but maybe there are a couple of areas where there is a head start for other countries or other businesses in the rest of the world. But most of this field is there's no defined blueprint, right? So this is what we discuss internally also. You'll not find these answers in Google. This is not something, or GitHub, right? So you'll not get anything when you're doing it.
Yeah. No, it's interesting. So I think predictive analytics is more or less a green field, and you are Wild West. You have to go and stumble upon and make mistakes.
I'm not saying predictive analytics per se. Predictive analytics is not that, but the other pieces of manufacturing analytics,
yeah,
especially related to quality or especially related to improving operations.
Right. And Purnesh, I just wanted to take one more tangential question. So you mentioned about ROI, right? And essentially, you're talking about parts per million and few defects, and still the ROI is pretty high if you solve that problem from machine learning, right? But in general, the question that I wanted to ask, and both Ramesh and you, right? Are you seeing a trend where technology people are trying to jump to a problem with machine learning and not looking at the ROI, like in the sense that even if I solve this with the particular reason, with some accuracy, is it really going to move the needle on my business in fact, right? And have you seen that, like people are just jumping to machine learning because it sounds sexy, it's marketable, but doesn't really have a significant business impact? And have you seen that? What do you see? You guys are industry practitioners, so what do you think about that problem?
Was the direct? Should I go first or?
Yeah, any one of you? I mean, Ramesh.
Okay, sure. Absolutely. I think you're spot on in the sense that yes, because I'll not, I won't blame the partners or the startups or the companies doing this also because it's their business model, right? So I would, it's up. End of the day, it's up to us to decide what's creating value. But to answer specifically, right, especially in the industrial space. I know this is a textbook answer, but trust me, we have learned this the hard way that domain knowledge is the most critical thing, right? So you can develop the most cutting edge machine learning model, or you can bring rocket scientists to build your model, but without proper domain knowledge, it's absolutely useless. This is where we have seen many startups struggle. To your point, right? So they're extremely smart people. Trying to trying to build a machine learning, throw machine learning at a problem instead of understanding the ground reality of the business or the process, or adding those building those constraints into the equation. But yeah, definitely. But again, right? So I'm not blaming anyone, right? So if someone is buying, that's good business. Who am I to blame? So
yeah, but you agree that is a problem in the sense that machine learning, just from marketing perspective, is fairly rampant. And Ramesh, any point of view on that?
Um, I'll agree with Purnesh. The industry tends to jump on, whatever is sexy, what is the next thing, and then just jump on it. But ultimately, the business invests time and resources in it. And there's an opportunity cost as well while you're doing that. And you have to know that if you're realizing the benefits or not. So when previously we focused on only one problem in terms of machine learning, that was churn prediction. And that was it, because we left everything else because we said, okay, fine, you know what? We'll spend, 100 hours, spit polishing this, but the returns to the business are very, very marginal. So we said, no, the only thing we said is a churn prediction, because a cost of acquiring a new customer is really, really, really expensive. So once you get a customer, what can I do to hold on to them, him or her? That is the more important thing. So that's what we did, and the accuracy of the model wasn't great, but still, it is still worth the cost of acquiring somebody new and using a model which will give us some signals which we can incentivize the customer to stay in the platform. So there are some signals to say, okay, you go to help page or you close something. So there's signals, each different business, each domain, there's different signals. And if you know that, if you can tack onto that and incentivize them, or even just a help desk call to them, an outbound call, and then you retain that customer, that's a big value. So we just focused on that one simple thing.
That's interesting. So even if machine learning is not completely accurate, even it can still have benefits in terms of, at least in certain problem spaces, and then that's the takeaway. And then Purnesh, from your point of view, you essentially said that the domain knowledge is the king, right? And don't approach machine learning problem with just algorithms and stats unless you really understand the domain really well. I think that's a key takeaway from me.
Right, and I totally agree with what Ramesh has said, and I like how he has put it. That even if you solve just one problem, but as long as you realize that that's your most important, or that's going to move your needle, right? That's important. Figuring out what is the most important problem that you need to solve, that rather than solving 100 problems just for the sake of it.
Yeah, great. So I just like one question, last question, right? And both for both of you, right? What are your top challenges, pain points in the space, right? And what are some things that you would like to see from tools or the open source ecosystem, essentially in this space, right? I don't know if you want to go first, Ramesh. You have some thoughts on that?
I think the technology is complex. You have to put all these Lego bricks together to arrive at a solution, and that requires a fair amount of investment and experimentation. And then if if the open source community or even some specialized consulting partners, and I work with some here who've got skill sets, but it's easily accessible to the startup community. I think that's key for me. I think that's a challenge which I found. Once you got, like you said, once you got a certain budget, certain skill sets, the problems are easy to solve. But especially what I've seen is startups need some of those technologies and solutions quite early, because you're struggling to grow the business, you're growing the business, and you're fighting with a lot of people to get the customers, and you need to retain the customers or stay ahead of it. And some of those real-time analytics and real-time information helps you stay ahead of the curve. But you're in a chicken and egg sort of situation where you need that, but you don't have the expertise or the skills. So if there's models out there which you can look at it, and I work with some companies where they'll provide you data analytics as a service, where you can amortize the cost over a 3-year period. So that sort of models works. Yeah.
Right, and Purnesh, you want to go next? I mean,
yeah, sure. Look, from a industrial analytics perspective, right? Maybe probably at least the pain point that we face every day is I can't imagine that this is even a problem in 21st century, which is getting access to data from some obscure systems that is controlled by some OEM sitting. They're not even in India. No one knows where they're sitting. And maybe some out of some countries, some Western Europe country, or maybe North America, right? It's just unimaginable that I have to, or someone has to go through 10 different levels of whatever it is, rubbish to get access to my own data in 2020 is unimaginable, right? So this space, especially when you look at it, it's not open. That's it's when we look at a simple thing like the reason we trust a database, right? So, or while Oracle made a lot of money, while everyone trusts, is because there's ODBC connection. Anyone in the world can connect and then access data. There's absolutely no issues. That level of transparency, right? So whether good and bad, I'm not talking about the pros and cons, but they've helped standardize that across the industry, right? It's unimaginable that it's extremely painful that the data is not available to the businesses themselves. I believe it's true with most of
a lot of industries, yes.
lot of industrial manufacturing plants, right? So
my
that
data,
needs to change.
It's my data. It's sitting somewhere in this computer, but there's no way to access it.
There's no way to access it, and sometimes it's not even at my plant. It's somewhere there in a different server. So that definitely needs to change, and I hope this is where I hope to see a lot of progress. So.
Fantastic. Thank you, guys. At least I'm from my side, had the questions, but there are some questions that have come up, and I'll just pose it, and whoever feels that you think you want to take that. So there's a question from Azhar, and which is more around moving towards data lake to decentralized management. But are there any methods or solutions or challenges around access control, monitoring, who's using what, compliance? More around the data management, data governance side, right? Anything on, what are some of the challenges that over there you're seeing in the data governance space, access management, and how do you sort of work around that? Or how do you sort of, solve those problems? Or anyone, if Ramesh wants to take that or Purnesh wants to take that.
So if I just wanted to make sure I'm not answering, but I'm making sure I understand the question. Your question is more around how do you ensure data governance and
authorized people are accessing it especially in a data lake kind of a situation when you've taken all the real time and moved it to a data lake. What are some of the checks and balances in that data governance? Azhar, if you want to rephrase that, you can just unmute yourself and talk. But at least that's what I gathered from the question that was put up.
Okay. Maybe a short answer, right? So while the concept of data governance itself is very vast, maybe what I would say, at least from my experience, what I've seen is that the tools that these cloud providers have made it extremely, or maybe 10 times easier now to manage your access. They provide all the security reports out of the box, and then it has become a lot easier to manage your governance than it used to be. Earlier, it used to be a thing that only a large consultant could come and pitch you, saying that you'll need to do a 1-year transformation project to do it. But I don't think it's the case anymore. I know it's a generic answer. That's because I'm not quite clear on the question. I apologize. If there's a follow-up question, I would be more than happy to answer.
So my question was around, when it was actually a data lake kind of a setup, it was very easy to really, control the access because of a centralized team handling it. So when you also mentioned that, it is a mess to handle a data lake, and a decentralized approach is far better, right? So I kind of agree to that, but there is a lot of benefits that was getting, like access control, reuse. There's only one code which is written, one centralized monitoring. So when you move away to a decentralized data management system, would it, all this complexity, is there any tools that is already available, or any methods, or any other solutions in place already, which solves this problem?
So first of all, I don't know if I've said that you should move away from data lake to decentralized. I don't know if I did. I did not mean that. You should not. I was arguing that both has pros and cons. I was saying that the only point that I was making earlier was that before you start a data lake project, you need to know why you are doing it, right? So in the sense that, but that said, answering your question, it's not easy. But for example, for us, right, so as part of my role, at least something that I used to do until last year, was we used to manage access across 10 businesses, multiple users and multiple data and multiple accounts and everything, both centralized and decentralized, in the sense that we had come up with again, this is where I would go back to my original question, that you need to know what is something that you cannot mess with. This is something I would put it as, you cannot mess with this access and all. You spend as much time as required to come up with the right architecture. And we have taken the time initially working with our partners and everyone to set up that with mostly out of the box tools that were provided by the cloud providers. We at least as for I can, if I'm not wrong, I believe we are still doing that, but I can, if you're looking for any specific tool name, sorry, I cannot give that.
Ramesh, this is one question for you, and this is more from the streaming solutions, and you're a fan of event streaming. So the question that's come up is there's a rise in the applying SQL related technologies to streaming solutions, right? And a lot of the vendors have that where you can run SQL queries against a continuous data stream. And so the question that at least I understood was, have you seen use cases of that? Are you seeing? Do you see that in that SQL in streaming context? Is it mature? Is it something that's being used? You've got some thoughts on that technology, not specific vendor, but that the general direction of SQL with real-time technologies. Any thoughts on that?
I think it's got a place, because if you look at, I'll take a couple of names. You got Kinesis on AWS for event streaming, or if you got Kafka or Confluent, you're going to, there's two approaches. One, you process the events as they come in, or you process, then you do a checkpoint, which requires you to write a service and do some stuff, to manage that. But you could potentially do that with a SQL solution pretty quickly. So it gives you a quick solution out of the box very quickly of doing that. But I think the intricacies of what do you want to do after that, you still have to handle it. It just solves a part of the puzzle out of the box quickly, but I don't think the rest of the stuff it gives you, at the end of the day, you still have to do the processing after that. And the other thing, it's a good tool set for people if they want to tap into the stream, and if there's a problem, or if there's and then do a quick analysis. without having to write a big service, and you just want to go in and have a look. Yeah, that's good, I think. And this for people like financial analysts or business analysts or a data analyst, they want to have a quick look at it without having to go to the data lake. They want to look at it, and if there's a problem and there's an immediate sort of thing. So those sort of SQL solutions which tap into the stream, I think they're good.
Yeah, so you're saying it's a good tool for introspection, looking at a stream, and also for there's certain use cases, but you still have to build on top of it. It's not the be all end all. You still
it is not. No, yeah.
Yeah, great. Thanks, Ramesh, for that.
We have one more question. This is from Govinda, right? And this is for the panel, no one in specific. So his question is, the accuracy of a model depends on the training data and parameters to be trained upon. The hardest part is to identify those parameters. So is more number of parameters always a good strategy?
Especially, not necessarily, not at all. In fact, you would find many of the forecasting projects, or especially price or demand that we work on or anything, right? You'll not even have a lot of data points. You'll have a very small data set, but you'll have to aim for getting a very high accuracy. So that's the challenge.
Ramesh and Purnesh, thank you so much, and for taking the time off. I enjoyed. I learned quite a few things, and it's a great to have you on our show. So thank you so much.
Thank you, guys.
Thank you, Haston.
Yeah, thanks, Purnesh.